see gradient function, the moment you see gradient, okay, function, the moment you see gradient is dy dx. It's not y, okay? It doesn't mean that function is y, but function itself is y, but there is a gradient, it becomes dy dx. All right, remember this. So the moment you see gradient function, you have to write dy dx of the function gradient here at a point. Okay, function, it means a graph. Gradient means the dy dx. Okay, remember this, dy dx is gradient function. Okay, the gradient function given is px plus 2, where p is a constant. When you see constant, it means number, any number. All right, that means when you find the answer later, you'll get a number for the p. Given that the normal gradient, this normal is going to make a right angle with the dy dx. So meaning that this is m2. Quickly you write the concept. That means the dy dx will be your m1. Right? When you see normal and tangent or gradient of the function given, your brain must appear this concept, m1 times m2 equal to negative 1. The moment you see normal or dy dx, m1, m2 is negative 1. So if they give you normal, you can find dy dx. Okay, the question say the normal gradient is negative 1 over 6 m2. So very fast you will find the m1, just inverse the 6 over 1. If this is negative, it becomes positive. So your m1 is actually negative 1 over m2, right? So m1 is negative 1 over. So you will definitely get a number which is inverse of this, and the sign will be opposite. All right, so now once you got the m1, it means that you got a dy dx. See or not? So m1 is dy dx. m1 is dy dx. m2 is the normal. So at this point, they sure will give you the x. They must be at a point dy dx. All right. So the point given is 1. We just focus to the x. You want to use a y later on when you want to find a c. So we use an x, substitute here. We can solve the p, right? p1 plus 2 equal to 6. P is 6 minus 2. So p is 4. So p is a constant. Value of the p is 4. All right. That is number 1. For number 2,